So today we're going to learn about parent functions. Parent functions. They're called parent functions because it's like a family. We're going to have a parent, and then they're going to have like offspring. They're going to look kind of like them, but not exactly the same. There are lots of parent functions. We're going to just look at 4 of them today. The 4 families we're going to look at are the constants, Mr. and Mrs. Constant and their kids, yep. The linears, the absolute values, and the quadratics. Those are the parent function families. Let's just look at constant to start with. The rule for constant, the function, the f of x is 1. That's the function. What does f of x another? Y. It's y equals 1. That's another way of saying f of x. Y equals 1. So the parent function of a constant is 1. The graph looks like a horizontal line. That is the family trait, I guess. That's what all of the constant lines look like, horizontal. Now, domain and range, possibly heard of that from a previous course, maybe? So domain, does anybody remember anything about domain? No? Okay. So domain is the input value. It's what you put into the equation. When you go and you plug stuff into an equation, we put it into the x spot. So the input is also the x values. The x values. Domain is also everything to the left and to the right of the graph. Everything to the left and right. So I'm going to write left and right. That's the domain. And then the range. Anybody know anything about the range? After I wrote domain, does anybody know anything about the range? Read. It is the output. Excellent. Did you know that or did you just figure it out?
I think
It's been a while. Whoops. It is the output. Here, I'll put it in a different color. Purple. Output. Somebody else tell me something. It is the, compare it here. It is the y values. Good. And instead of left and right, it is the up and down and up. So the domain of the constant family, when we look visually at this graph, how far does it go to the left and how far does it go to the right? What's the arrow mean? Forever. It goes to infinity, both directions. So we write the domain as being all real numbers because it's everything. And then the range is the up and the down. How far down does it go or how far up does it go is this? It's not, is it? It's just like here. So the range for this one is only y equals 1. And if I were to list all the ordered pairs on this line, well, I can't list all of them. There's infinitely many. But if I were to list a select few of them, you will see, and you should copy these down, you will see that -2, 1, -1, 1, 0, 1, 1, 1, 2, 1. You'll see that the y values are all just 1. So that's our range. So go ahead and take a moment. I'll just leave this up. We've got 4 different ones to copy down, and then I'll go over the rest of it. But we are going to need these values later in our notes, so copy them down. I'll just sit here and say, copy them down. I left you like an inch to copy down. Not much, just a little bit. Each of those goes with the graph right above it.
You can copy down the other ones too already.
While you're copying your tables down, the first column is the x's. That's always the domain. That's always what we input into the equation. The second column is the f of x, or the y, or the output, or the range. The second column is the range. Okay, these will come back up. I'm just going to scoot up a little bit so we can look at the next one. If you didn't copy them all down, they will be right back up. So the next parent function is from the linear family. The linear family starts with the parent f of x equals x. That's the parent function. F of x equals x. Same thing as y equals x. And the linear family are lines other than horizontal or vertical. It's all the ones in between the horizontal and vertical. You can see here the parent function goes exactly in the middle of the x and y axis. It's right in the middle. The ordered pairs for the parent function, if I inputted 1, then y would also be 1. If I put in 2, y would also be 2. If I put in -1 for x, y would also be -1. So you can see all the ordered pairs are the same for the linear parent function. The domain is left to right. So how far does this graph go to the left? What's the arrow mean? How far does it go to the right? What's the arrow mean? Forever. So it goes forever to the left, forever to the right. Domain is all real numbers. And then up and down, you can see it's angled down, and then it's angled up. How far does it go down, and how far does it go up? Forever. All real numbers. So that's the domain and range for the linear family. That's always the domain and range for the linear family. And then the ordered pairs I've given you. Next is the absolute value family. The absolute value family has those absolute value bars around the x, and the shape of the absolute value family is always a V. That's not a Q, right? It's a V. I don't know, I just picture. Okay, how can we remember the absolute value makes a V? What's so funny? Okay, so you all should know that if you're graphing absolute value, it makes a V. V. Not a U. A V. Okay. The parent function, do you know what absolute value does to a number? What's it do? It's always positive, right? So if I plug in 1, then I get out 1. If I plug in -1, then I get out +1. So you'll see in my ordered pairs down here, there's only positive numbers. And then when we look at our domain and range, we can plug any number in to the absolute value, but we only get out positives. So to write the positive numbers, we say that the y values are greater than or equal to 0. That's our range. And then the last one is the quadratic parent function. The quadratic parent function is the U shape. Quadratic is x squared. So x squared, if I think about a square, has 4 sides. Quadratic. Square, 4 sides. Quadratic. Quad, get it? Geometry, y'all took geometry. Okay. And kindergarten. 4. Okay. So the ordered pairs, when I plug in like 1 and I square it, 1 times 1 is 1. If I plug in 2 and I square it, 2 times 2 is 4. But if I plug in -1 and I square it, -1 times -1 is +1. And if I put in input -2 and I do -2 squared, I get out +4. So if I input any numbers, I always get positive numbers out. When you square a number, it becomes positive. So our domain, we can have all real numbers. It goes all the way to the left, all the way to the right. You can put anything in there, but you get out only positive. So y is greater than or equal to 0. I'm saying positive. 0 is not a positive. Because if you put in 0, you get out 0. So non-negative answers. Okay. Everybody has these copied down. I can stop talking and move on. All right. Next. Here we have 4 graphs. Can you quickly take a moment on your own and write the name of the function family? What family do each of those graphs belong to? If you've forgotten, it's on the previous page. Today we're doing a lot of vocabulary, so you might have to keep looking in your notes until you learn the vocabulary. It's okay. All right, so the first one is, help me out. More than 2 people? Linear. Second one is constant. Next, quadratic. And the last one, absolute value. Okay, next is write the equation. So the first one, this one, if you look carefully, it does go through 1, 1, 2, 2, 3, 3. So this is f of x equals x. It is the parent function. You could have also written y equals x. Either would be fine. The next one, constant. Be careful because this one is a tricky one. What order pairs is it going through? Is it going through 1 every time? What's it going through? What's an ordered pair? 0, 2, 1, 2, 2. I'm just looking at the ordered pairs. You guys see where I'm looking? What's another ordered pair? Huh? I can't hear. Do you guys know I'm deaf? No. Jessica, give me an ordered pair. 3, 2. Excellent. Matt, give me an ordered pair. 4, 2. Oh my gosh, you guys are so smart. All right, so f of x is equal to, what is it equal to every single time? Something differs, but something's the same every single time. Oh gosh, I'm making it too hard. It's just the y value is 2 every single time. That says y equals 2. And you look at the ordered pairs, the y is always 2. That's the equation of that line. In your homework yesterday, you had to graph. I don't know if you graphed y equals 2. I feel like that was on the homework actually. It was number 10. So we graphed that one even, and it looked just like that. Okay, the next one, these are the parent functions. So f of x equals x squared, and f of x equals absolute value of x. Or you could say y equals, that's fine. The second one, the constant, that was the only one that wasn't the parent function. All right. Now, what I need you to do is, I've done something to this graph and I need you to do the same thing. What I did was I used those ordered pairs that we listed on the first page for the parent function, and I want you to dash it on this graph so that you end up having 2 graphs. See, one of them's dashed, that one you don't have. So go look at your parent function values for this family. What family is this one? What shape? Absolute value, right. So go look at the parent function for absolute value. And plot those ordered pairs we wrote down. You plot them, the ones we wrote down for the parent function. The one that's graphed is not the parent function. You plot the parent function on top of that graph. I gotta go look those ones up. And I dashed it because it's not the original, it's the parent, that's why it's dashed. The new function is the one that's solid, so we can tell the difference between the parent and the new function. Okay, in the directions, it says to identify the function family, use the vocabulary word bank to compare the graph of f to the graph of its parent function, and then list the domain and range. But I did not give you this blue part. And same thing in homework. You're going to do this in your homework, but I didn't write this part down. So you're going to have to read the directions to know what to write down. But I'm telling you, it's the exact same thing in your homework. So when you get to this part in your homework, look at your notes. It's the same. So the first thing we're going to list is what family it belongs to, which you guys already told me absolute value. Next, we're going to talk about transformations. And you did that in geometry. You did transformations. Transformations would be like how the parent function changes to make this blue new function. So if we have the parent function looking like this, and then our new function is look exactly the same, can you maybe use some terminology down here to describe how the blue one is different? See, you have that same chart here. Is there anything you notice that's different? Check. It's up one. Excellent. Do you guys notice it's a little bit higher? So down here I'm looking for up, and here's the word up. You all are learning vocabulary. So that big word in front of it is a main word that I want to see on your paper. I want to see, oops, sorry. I want to see that it was, what happened? Do you know what I touched? It worked. Okay, so the main word that I want to see up here, transformations, I want to see translate. Translate. And then we'll say up 1 unit. Okay. So you are learning vocabulary. You need to write the word translate. That is part of the lesson. Is that the only difference that it moved up one? Is that the only difference? So what else happened?
Horizontal stretch.
Ooh. So you were thinking that it got wider, right? Horizontal stretch, you got that it wider. You guys agree it looks wider? Okay, so when we talk about wider, it could be a horizontal stretch, but it also could be a vertical shrink. And there is a way to tell the difference, but we're not going to learn that today. We will learn that. So for now, we're just going to put or. We'll write either a vertical shrink or a horizontal stretch. And we will learn what the right one is. Just heads up, it is a vertical shrink. No, it is not. It is not a vertical shrink. Oh, it did not get wider, though. Just kidding. Let's try that again. It did not get wider. Backing it up. From the orange one to the blue one. You were thinking the other way, weren't you? From the orange one, from the parent to the baby. From the orange one, from the orange one to the baby, other way. It got narrower. So it's a vertical, let's try that again, vertical what? Stretch or a horizontal shrink. Just gotta make sure we know which direction we're going. We always start at the parent, then go to the new one. Okay. And then back to what I was saying. It is a vertical stretch, but we'll learn why later. Okay. Then domain. Domain is the x's. It is the input. It is the left to right. So if you look at the blue graph, how far does it go to the left? How far does it go to the right? What do the arrows mean? Forever. So then domain is all real numbers. The range is down to up. So we look, what is the furthest down that this graph goes? The blue one. What's the furthest down? So like, use your pencil and make a horizontal line and go down, 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 down. What's the furthest down it goes? 1. You see the graph goes to here. It does not go past that point. So 1 is the furthest down it goes. From there, it keeps going up and up and up for how long? Ever. Right, so the range starts at 1 and goes above. So y is greater than or equal to 1. That's the range. Let's try it again. Different example. Okay, so this one is what parent family? What family? Quadratic. So go look at your quadratic point and plot the parent function and dash it. Quadratic. Look at those points. Quadratic family, plot those parent function points. Once you get them plotted, start thinking about how the parent function changes into the new function. Good, I'm walking around, I see some really good graphs on there. It's okay if you need to go off the graph provided to plot those points. It's okay to go off the graph. Oh, tomorrow. All right, so I have my orange graph. That is the parent function, and the blue one is the new function. How does it change from the parent to the new? What is something that is transformed? Brianna?
Yes, it translates right through.
Excellent. Okay, we translated right 3 units. Thank you for using the correct vocabulary. Is there anything else different?
There's a horizontal stretch.
So you are thinking that it is wider? Yeah. Is it only a horizontal stretch, or could it be something else on that list? Horizontal stretch or a vertical shrink. It could be either, and you don't know which one yet. And I will tell you it is a vertical shrink. So, but we'll find out why later. Domain. How far to the left and how far to the right does it go? Forever. So it is all real numbers. numbers. And then range, how far down and how far up? How far down is it? 0. And then how far up? Right. So y is greater than or equal to 0. It starts at 0, goes up. That's the range. Almost done. We got like one more little thing to learn. So we are going to be talking about transformations almost the entire book. It's just going to keep coming up for different equations. At the end of the year, we'll be doing logarithms. You've ever heard of those? So we'll be doing something called logarithms or exponential equations, and we'll be doing transformations with those. So we're going to like learn different equations and graphs throughout the year, and then we're going to do transformations with all these different kinds. So this topic is not something you can be like, yeah, I don't really get it. Move on, because it comes up over and over and over and over and over again. So let's really ask good questions and get it now, as soon as possible. So today we're just going to talk about translations. And a translation, that's the kind that we could slide left or right, or we could slide up or down. But when we do the sliding, you're using the word translate, because that is our mature Algebra 2 vocabulary you're learning. Okay, translate. It means slide. If we are doing a vertical translation, oh, by the way, this is an example of a translation, something you want to see. Do you see the R on yours? And do you see the R with apostrophe? You have R with the apostrophe is called R prime. And that tells you that R is the original, the image, no, pre-image, and then R prime is the image. Did you do that in geometry? You should have. Okay, so that tells you which one is the original. Because to get from R to R prime, we would go down 4, right 6. But if you had it backwards, you'd have the wrong operation. So we need to know which one's the original. That's all that's for. Now, to do a vertical translation, you're going to have a function. See, f of x, you're going to have a function, and you'll either add a number, k is just the number, or you will subtract a number. So you're going to start with a function, you'll either add a number or subtract a number. The function, the f of x, that is a parent function. So anytime you see that f of x here, we're talking about a parent function. So we take a parent function and we add a number. What it's going to do to the graph is it's going to move it up. If we take a parent function and we subtract a number, that takes that graph and it slides it down. All right? So that is vertical translation. Horizontal translation is a little bit more confusing. You see how it has like a parenthesis? So if it's a horizontal translation, you will know when you look at the equation, there's probably going to be a number being added or subtracted inside of a parenthesis. That's a big hint that it is a horizontal translation. That's a big hint. And when you do any horizontal translation throughout the entire year, when we do it, anytime we do horizontal translations, they end up being opposite of what you'd think they would be. So like with vertical, when I added k, it went up. But with horizontal, if I add h, see right here, if I add h, it actually goes to the left. So it's opposite of what you would think. If I subtract a number, it actually makes it go to the right. So a little bit confusing because you got to think opposite if it's horizontal. Anything that we do horizontal is opposite. Vertical is just the way you think it would be. So I'm just going to put a couple examples that are not on your paper. I'm just going to throw some up there and you can see how this works with a parent function. So if I have a parent function and I'm going to use the linear family, and if I take that and I say minus 2, you're going to look at this and you're going to say, all right, I've got a parent function, we got a minus 2. Is there any parentheses? No, so that means it's going to be a vertical. So which one is it? Down. This is a translate down 2 units. So what if I said, all right, how about f of x is equal to x minus 3 in parentheses? So you see those parentheses and you see that minus 3 is inside the parentheses with the x? That tells me it's a horizontal. And then we go over here and we say, all right, the one that's a minus is opposite of what I think. I'm going to go to the right instead of to the left. I'm going to go to the right. Translate right. How many? 3. So this very last example, we're going to graph. And it's called it g of x instead of f of x. It's still a function. G of x and its parent function. Then describe the transformation. So we have to graph this function and its parent. So we got to know what its parent function is. So g of x equals x minus 4. What family does it belong to? If you're not sure, go back and look at your equations. Which family has an x? David?
Linear.
Linear, perfect. Linear. The parent function for the linear is f of x equals x. So this one is x minus 4. How is that one different than x? What do we have? We have that minus 4. Is it in parentheses? So is this vertical or horizontal? Vertical. So we're going to translate it. It's going to be vertical. And when it's vertical, the sign is the same. So if it says minus 4, where is it translating vertically? Down 4. So now what we're going to do is we're going to go graph the parent function. And we wrote down those ordered pairs. The parent function. What's the parent function for the linear? Go look at those ordered pairs. Somebody give me some of them. Call some out. -2, -2. -1, -1. Good teamwork. Keep going. 0, 0. Thanks. I didn't hear that one. 1, 1. 2, 2. So there's our parent function. Now how the transformation works is we translate each of those individual points that we just graphed down 4. Let's take each of those points and graph a new one that is down 4 from it. Just count down 4. Down 4. So we just took each of those points and we moved it down 4. Okay, so I'm going to pass out your assignment. It is a worksheet, and there are questions just like what we did in class, and there's a couple to see how much you're thinking. I would encourage you to use your notes. That's what they're for. It's like a handbook on how to do it, especially because I haven't handed out books yet. Is there anybody that did not do the big ideas thing yet because we're having computer issues? You didn't, anybody else not do the computer assignment yet? Everybody else has done it? Can you get on camera and see the paper version? Make sure you can't get on it at home or you finish that. This down camera, you want to kind of Please, that's okay. Thank you. So what do you mean? Like, does it have to have like a definite